people. Today we're going to find out the rate of convergence for the Newton-Raphson method. Finding out the rate of convergence for the Newton-Raphson method usually starts as usual as how we have seen in the last video. Now, this is the recurrent solution for the Newton-Raphson method. However, to further proceed on, we are going to start by using the Newton-Raphson's formula. As usual, I've written the step-by-step procedure here. It will be easy for you all to follow up. It will not be as difficult as what it seems. So, if you're interested in my lecture, you can listen to my lecture and glance to the video maybe. Let's get into the video. Okay, so this is the Newton-Raphson's formula. This is what we're talking about, and this is what we're going to do. Consider this formula. Of course, f of k is the same as f of xk because it is an approximate root. And the same f dash of k is the same as f dash of xk because it is an approximate root. Now, xk is basically equal to r plus epsilon k. The same goes for xk plus 1, which is r plus epsilon k plus 1. Now, you just compare 1 and 2. By doing so, you get this equation 3. Now, we need to find out f of xk and we need to find out f dash of xk in order to proceed on further on. As usual, you will neglect epsilon k cube. Epsilon k cube will be neglected because it is a very small value, 0.0001, which is almost negligible. So on expanding this by Taylor series, we neglect it because it's not necessary. It would be negligible. It would be making no sense to involve it. Even if you involve it, it would not make a big difference. To make the sum easy, I've also included it up to epsilon k square, which is much more easy. Now, put f of xk and f dash of xk in the above equation 3. By doing so, you get this particular term. This only has to be further simplified. Can you see here? The simplification is as simple as follows. And oh guys, r plus epsilon k plus 1 on the left hand side has come as such because that is the definition of x suffix k plus 1. Now, but make sure that you understand that f of r is equal to 0 because it is a root. We need not get into this. There's a big explanation about this, but since you'll just want to understand what it is and how it comes, f of r just equals to 0. To make things easy, I'm not explaining about this part. So f of r becomes 0 and thus giving you this particular step as what you see in this particular step. Now, you're just going to take out f dash of r and epsilon k in the numerator as a common thing and f dash of r as a common thing in the denominator. Both of them obviously gets cancelled. As you can see, it's not a difficult task. Now it's just going to be further simplification which is going to help you. Both gets cancelled out again, which is f dash of r and f dash of r, and let this particular term in the denominator after the 1 in addition be written as x. That is made in order to make your sums be solved more easier. Now we're just going to further proceed on to solve this problem. Can you see that x? It's just what has happened. To make it easier, f dash of r gets cancelled, it's obvious, and 1 plus x comes to the numerator and you will be expanding it in the form of binomial series. By doing so, it's just a normal expanding process. In the same way, epsilon k cube onwards can be neglected here. And you can just proceed on and you get this step, which is obvious. Now, this particular step has been brought this way because that is the value of x. The value of x is what I've been substituting here. So, if in so where the x is, it's a general term, and where the x square is, it's that term, the whole square. Now let's C1 be as what I've mentioned it, and let's C2 be as what I mentioned. That is going to give you this particular term in which I have kept here. Just further simplify it. By further simplifying it, you're going to get this step. Now you know the value of C1 and C2 is what I've mentioned about. So this is the value of what I've put here. And can you see epsilon k cube? I've mentioned it that it becomes 0 because it's a negligible thing. Likewise, epsilon k4 also becomes 0. That's why the product with it becomes 0. And then you get the next step in which follows. It's a further simplification of the next step. It's simple, it's not that hard. And obviously, epsilon k cube with the product of these terms becomes 0. It's a negligible term, guys. It's nothing that epsilon k cube can be neglected. It's not that hard for you to understand. We just proceed on with the same step. You guys will definitely be understanding this step. It's not that difficult. And hence, by further simplifying it, again, can you see the epsilon k cube? Yeah, that term is negligible. That term is taken as 0, so that term goes off. Epsilon k minus epsilon k gets cancelled, thus leaving us with this particular term. This whole term in product with epsilon k square is actually c, which we are going to assume it to be, so that it remains a constant. Thus we get epsilon k plus 1 equals to c into epsilon k square. It's the same assumption we're going to make, which is epsilon k plus 1 equals to a into epsilon k to the power of b. Suffixes should just be replaced. K plus 1 with its less term k with its k minus 1 term, thus giving us this term. And now we put these values, epsilon k and epsilon k minus 1 value, in epsilon k plus 1, which equals to c into epsilon k square. Just do it. By doing so, you get a simple term. Just simplify it further, and just equate the like terms. By doing so, you get the number 2. I hope you guys enjoyed this video. If you loved it, give a thumbs up to it, and if you find it useful, share it to someone who you think would appreciate this video. Thank you.